this video is about the Bernoulli's equation. So we're going to look at how we can solve Bernoulli equation and also how we can also find the general solution using Bernoulli's equation. So make sure you watch this video to the end. So now we're going to take an example of a question related to Bernoulli's equation and we'll try solving it. Please make sure you watch this video to the end. So now we have this question which says that the derivative of y plus y is equal to bracket open xy squared. Now first you need to identify how to solve this and change this to the linear form. So now we have something, this is the Bernoulli's equation, so it's always represented by this. So we need to change this into linear form. After changing to linear form, and we continue solving it, finding the integral, and also we find the integrating factor, multiply through, and we integrate and get our general solution. So now this is the question we are going to solve with, and please make sure you watch this video to the end. So now we have this. We try expanding the bracket. The whole idea of Bernoulli's equation is to make this one linear. After making it linear, we try finding the integrating factor, multiply through, and after we take the integral of it, and we are done. So now let's go. So now we expand this bracket, which means that the square will affect this x and affect this y, making the equation this way. That is. Now, the whole idea of it is that the next step to do is to multiply, or that is to multiply through by 1 over y squared. Simply to divide through by 1, that's to divide through by y squared. So we are going to divide through by y squared. So that's the first thing, we are going to divide through by the y squared. Yes, but always note that when the question is given to you and the coefficient of this is with a variable, you first divide through by that before you divide through by the y squared. So when you divide through by y squared, you're going to get this y squared. So always we divide through by the exponent of the y, that is this. We divide through by this. So now, when you divide through by that, this, we're going to take care of this, leaving this. So when you try bringing this one forward with the laws of indices, you know that this becomes negative 2. That's y raised to the power negative 2 times y prime plus, you know this, when you solve, you're going to get y exponent 1 minus 2. So when you do that, you're going to get y exponent negative 1, and this will give you x squared. After getting this, now the Bernoulli's theory, or the Bernoulli's equation, use substitution. So we are going to use substitution for this. Please watch this one very careful. So with the substitution, you are going to make a variable be equal to the px. So we are going to make a z be equal to what? Y minus, that is y exponent negative 1. That is, we are making p be equal to this. So always you try dividing this so that we can get something like this and make p be equal to the y with the exponent. So when you make z equal to this, the next step to do is you try to what? Differentiate this. And in the way, when you differentiate this, you know that this will be minus 1 and this will be minus 1. So you're going to get, that is y exponent negative 1. When you are differentiating this, that is z prime, you're going to get, that is, you will first bring this one from, that will be negative, and y, you get negative 1 minus 1, which will give you y exponent negative 2. Why? Because you are doing respect to x, so y prime, that is implicit function. So we get this. Now after getting these two, you try doing substitution. So we are going to try substituting this into the equation to make the equation linear. So as you can see that z is equal to this, and z prime, you can just fix it out when you factorize negative 1 out. as in when you close this bracket. It's similar to this. So you what? Do substitution. After doing substitution, you know that you get a linear form which is this way. So if you reduce the complex differential equation into a linear form. Now what you do now is, for here you can try making the z prime positive, which will be equal to z prime plus, okay, sorry, so when trying to make it, so we are going to get z prime minus z is equal to negative x squared. So we try making the z prime positive. After that, what to do now is, we've now changed this form into this. So we've changed this one into a linear form. So after that, what did you do? Now you try finding the integrating factor. And with the integrating factor, it is what? E exponent, the integral of px. Now the px is the variable with x. As you can see, the variable with z, the variable with z. And here, luckily we have nothing with z, but it means that we have 1 here. Therefore, when you compare it here, it means that the p of x will be equal to -1, right? As simple as that. You know that we can express the z in a form of y. So don't be confused why we have y here. We can express z in the form of y. So it is what? -1. So when you do that, we're going to find the e exponent, the integral of -1 dx, and that will give you the integrating factor will give you -x. As simple as that. So after getting the integrating factor, you multiply through it with a linear equation. So you are going to multiply through the integrating factor with a linear equation we got. So when you do that, when you are done with that, note this trick. You're going to take this side and equate it to this. After, you integrate this side, leaving this side. So when you do that correctly, we have ze exponent -x is equal to negative the integral. Note that the x squared is with negative, so it means that negative will come outside, giving the integral sign inside. So when you do that correctly, note this, you take this and you take that and you find the integral. You are going to use integration by path, because you cannot just integrate this simply as that. So you are going to use integrating by path. So uv minus the integral of v du. So when you are done with that, you take your u, this being your u, and this being your v. So one being your u, one being your v, and you do that. So after taking that, when you do that correctly, you're going to get this as the final answer. Now, as the final answer, you try making z the subject. So you can divide through by z, and when you divide through by z, you are going to get this. The reason why this one came out as positive is because z over e exponent -x with indices, it can be reduced as z e exponent positive x. As simple as that. Now, you know that we let our z be equal to y exponent -1. So when you substitute, you know that y exponent -1 is the same as y exponent -1 is the same as 1 over y in indices. And when you do that, you try making y the subject, and when you make y the subject, this is what you get. So this is the general solution for the Bernoulli's equation. Yes. So thank you very much for watching this video, and please subscribe for more videos. Bye.